Welcome to our last module, experimental chemistry. So here we're going to talk about actual techniques that you might use to analyze chemical reactions. Okay, so let me give you a flavor for some different ways that people might analyze what the heck is going on after a reaction happened. Okay, so one commonly used technique is something called recrystallization. Recrystallization is a pretty common way to purify solids. And so the idea is that solids and other impurities, which might also be solids, can be separated from each other by what's called selective dissolution, which basically means that some of the things will dissolve and some of them will not. And so what I'll do is I'll pick a solvent that will dissolve the solid when the temperature is high, but not when the temperature is low. Okay, so as I heat this up, all of the solid that I care about, that I want, will go into solution, and the solid impurities that I don't want are going to be left behind. At this point, I can very easily just filter or pour out all of the remaining impurities. And then the liquid that I have left over is going to contain all of the solid that I do want. But the liquid's hot, okay? And so if I let it cool, all of the extra solid that was in there in the first place will start to crystallize, okay? And then I can recover pure solid. And the nice thing about this is, even if the solid that I get is not 100% pure the first time around, I can repeat this multiple times. And this iterative process allows me to get higher and higher and higher purities of my crystalline material. Another commonly used technique is something called distillation. Distillation involves separating liquids rather than solids, like we did before, based on boiling points rather than solubilities. Okay, and so to separate things based on their boiling points, I have to worry about something called vapor pressure. Okay, and so vapor pressure is nothing more than the pressure that a gas is exerting on a liquid when we're at equilibrium. And when something is boiling, that means that the vapor pressure of the substance is equal to the atmospheric pressure on the outside, okay, like over here. So let me show you a figure that compares the vapor pressures of different substances to each other. So if we look here, my y-axis here is pressure, in this case kilopascals, and my x-axis here is temperature. And these are vapor pressure curves for different substances, okay, diethyl ether, ethyl alcohol, water, and ethylene glycol. And you can see that for all of these things, as temperature increases, vapor pressure also increases. That means that if I lower the pressure outside, atmospherically, then I can have boiling occurring more easily, okay? Because if I can get the vapor pressure to be the same as the atmospheric pressure, something is going to boil more readily, okay? And so the lower the external pressure, the more easily something is going to boil. There are also just inherent differences in volatilities as well. Okay? And so things like ethyl ether have much higher vapor pressures at a given temperature, let's say 80 degrees Celsius, compared to water or ethylene glycol. Okay? And you can see that here, right? At different temperatures, things have different vapor pressures. Okay? And so, for example, the boiling point for ethyl ether is going to be about 35 degrees Celsius, normal boiling point. Whereas for ethanol or ethyl alcohol, that's about 78 degrees Celsius. And for water, that's about 100 degrees Celsius. So here's a diagram of what a simple distillation setup looks like. Okay, the way distillation works is you start out by having a flask that contains all of the liquids that are going to be present in your reaction mixture. And you start to heat this up, okay? And when you heat it up, the liquid starts to boil, or at least whatever is more volatile starts to boil. Okay, and so the more volatile things start to go up, and eventually they cross into something called the condenser. So the condenser, as the name implies, condenses the gas. The condenser is really just a tube inside of another tube. And on the outer tube, I have water that is circulating across the condenser, cold water that circulates around the condenser. Okay, and so water goes in over here, water goes out over there, And the idea is that I have vapor being produced this way, which is hot. So when the hot vapor is in kind of close contact to the cold water, I have an exchange of heat. Okay, heat gets transferred. The water warms up a little bit, right? It gains some energy from the vapor, but more importantly, the vapor loses energy. And so when the vapor loses energy, it actually undergoes a transition and cools back down into a liquid. So that by the time it leaves over here in my receiving flask, it's a liquid. So this is what allows me to separate liquids from each other based on their boiling points, right? I temporarily convert something into a gas, and then I collect it as a liquid again, thanks to this condenser. So this is called simple distillation. So then the next thing I want to show you is something called fractional distillation. Fractional distillation is more useful when the mixture has liquids that are a little bit closer together in their boiling points, right? Maybe they differ by like 10 degrees Celsius or so. So I can't really do a simple distillation and expect to get good separation. Okay, the way fractional distillation differs from simple distillation is there's an actual column in there with lots of little indentations or crevices, which increases the surface area and makes it easier for the separation to happen by having this greater surface area present. Okay? So this will hopefully give me purer compounds. And then the last thing I want to tell you about is something called extraction. Extraction is a technique that is used to purify either liquid-liquid or liquid-solid systems. These are based on different intermolecular forces and polarities. Okay, and so they're used pretty commonly in organic reactions to kind of remove substances from each other. Just like crystallization, we can do this iteratively as well. And when you do this iteratively, you can do it under the same conditions to get a higher recovery, just more and more stuff out of your extract, or you can do it under different conditions to get different compounds present. Okay, for example, natural product isolation. You may have heard of these people who go to kind of exotic locations like tropical islands, and they find something in like a leaf or a mushroom or something like that that has some kind of medicinal purposes. And what they do is they extract it from these kind of materials by techniques like this, right? They take the leaf or the mushroom and they kind of crush it up, and then they expose it to different solvents, like maybe water or alcohol or dichloromethane or chloroform or various things. And each of these solvents is going to extract different compounds because it's going to dissolve different kinds of substances. And then they would go and analyze each of these different fractions, or each of these different extracts, and see what's in there and what has maybe a desired biological effect. Okay, and then the final thing that I want to talk about in terms of experimental techniques is something called chromatography. Chromatography is a separation of compounds based solely on polarity. Okay, and this is pretty useful, pretty easy to do, more effective than extraction in terms of identifying the number of components in a mixture. Okay, and so I can tell you how many things are present because chromatography will separate them for me. And so I'll see them usually as spots on a plate. And so the more spots I have, the more compounds I have. And I can usually just count the spots and see how many different substances there are. I have no idea what they are. Okay, that's coming up later. But at least for now, I can tell you how many different components there are. I can also use this to separate things that are very similar in nature to each other, although it becomes difficult to do the closer and closer they are in terms of their properties. Okay, and so like all of these techniques, the more different things are, the more easily they're separated.